you guys through Canvas so you know where stuff is, and to go over the syllabus really quickly here on the first day of the course. When you open Canvas for the class, you should land on this home page. This home page has links to important stuff. First is the syllabus, which you should all read. I'm going to go over it quickly today, but I'm not going to go over every single word of it. Next is the online astronomy book. Let me open that in a separate tab. We're using a free astronomy textbook from a company called OpenStax. You may have had a course before that uses OpenStax. They make free textbooks for a lot of topics. You can read it in your web browser, or you can download a PDF, whichever you like. Actually, you can buy these. You can order a $50 printed copy of the book, but it doesn't really seem worth it for me when it's free and you can view it online anywhere you want. So that's the textbook. You will have readings in the textbook after almost every video I post. Announcements. I will use announcements a lot in the online class, more than I do in my NC classes. Usually once a week I'll post an announcement saying, hey, this is what's coming up, this is what's due. Sometimes if there's interesting stuff happening astronomically, interesting stuff in the news, I'll drop that in the announcements also. Check every couple of days to see what assignments are due. You'll see that in the main topic pages. I'll show you that in just a minute. There's some links here to some other OpenStax books just about being a student. They have little books about time management and how to study effectively. A book on college success, that kind of thing. I always put those links there in case students are interested. This is the most important part of Canvas here, the course content pages by topic. They are, there's 4 different pages. They're set up roughly by unit in the according to the structure of the course. So topic 1 is from, this date is wrong, I could change this date, from today, if you're watching this in the first day of class, from the 18th to about September 5th. You click on that, and what you will find is, these dates are right because I fixed these, every single day there will be links to the content of the course for that day. So this is the stuff you should do before the class. Watch this video that I'm making right now. Bookmark your astronomy textbook, and so on. Monday, watch the YouTube video about the scale of the cosmos. I try to put here how many minutes each video is. It's a 20-minute video. Read chapter section 1.5 through 1.7 in the textbook. Watch a really short video, 4-minute video. And then these are the assignments that are due this week. And I try to tell you when they are due. If not, you click on them, you'll get the due date. Tuesday, 22-minute video. Another chapter in the textbook, a little YouTube video by Carl Sagan. Wednesday, a 22-minute YouTube video by me. So you can see that the content is usually about a half hour a day, which means if you don't work on it every day, if you're working on it every other day, it's about the same as any in-seat class that meets for an hour and 15 minutes or so. If you get more than like 3-4 days behind, it's going to be hard to catch up. So I would recommend, if not every day, at least every other day, you set yourself a schedule and do your astronomy stuff. Week 2, all these dates are right, all the way through the end of week 4. No content on Labor Day. I try to not post new content on holidays and make sure to pace that week so that everybody stays on track. So that is where you will go every time you come to Canvas in order to find out what you're doing that day. Here on the home page, course content pages by topic. I'll gray these out as the dates pass. So obviously topic 1 is the date for the first few weeks. Topic 2 is weeks 5 through 8 or so. And a lot of this future stuff is super outdated because it's from the 2022 version of the class, and I haven't changed all the dates yet. But that's what I'll be doing this week and next week. The other important thing to look at here, so here's the assignments. Oops, that's the announcements. Here's the assignments. You won't see as many as are here on my page because there are a lot of unpublished assignments. You won't see the unpublished ones. But here's quiz 0. Quiz 0 is for on-campus students to find my office. I ask you to find my office on campus and answer some questions about my office, and to answer a question about the syllabus, which you can get by reading the syllabus or watching this video. So all the assignments should be clearly labeled with their due dates and how many points they're worth. The categories There's questions, there's quizzes, there's exams, your attendance on Canvas. Let's go to the syllabus really quickly so we can talk about the details. The syllabus, all your RBC syllabi should look the same. This is my contact information, RBC, dmorgan@rbc.edu is the best way to get a hold of me. I answer emails from students usually pretty quickly. I am usually on the internet until about 12:30 a.m. or 1 a.m. I won't necessarily answer your emails after midnight, but I'll probably see them if they get to me before 1 a.m. I have a hard time going to bed before 1 a.m. Email is the best way to reach me. There's a phone number here. Don't call the phone number. I don't really answer the phone. Send me an email if you need to reach me. My office hours are listed here. My office is McNear 123. You can swing by when these times are listed, or swing by anytime and look at my office door to see what other times available. Swing by just to see if I happen to be around. Let's see, Tuesday and Thursday afternoons I have physics lab, but the second half of that I'm usually just kind of hanging around the physics lab. That's a time that you can swing by and just ask a quick question or whatever about the class. The overview of the course, I'm not going to read all this verbatim, you can read this, but astronomy is interesting in that it is one of the oldest quote-unquote scientific fields of inquiry. In other words, one of the first things we started doing as a species is counting the number of days between summer and winter and noticing that the stars and planets move in different ways and keeping record of that. And you can actually see these organized observations of the sky as being kind of the start of what would become science. But it's also one of the one of the fastest moving fields of inquiry today. One of the things that's hard about teaching astronomy is it changes so quickly. Like Chemistry 101, if you teach Chemistry 101, nobody's discovering new chemistry that you teach in a 101 class in 2025, but they are discovering new stuff about astronomy every single year that immediately becomes relevant to even an introductory astronomy class like this. So it's super, super exciting to teach, and keeping up with astronomy is a challenge. Course objectives and outcomes. Again, I'm not going to read through all this verbatim. We're going to understand the essential principles of astronomy and cosmology. We're also, though, going to study how astronomy relates to physics. In order to understand how we know things in astronomy, we have to learn some physics. I'm actually a physicist by training, so we'll talk about a little bit of physics. One of the things I really want to stress in this class is how we know things. You've got some galaxy that's 1 million light years away. How do we know how massive it is and how many stars are in it and what's made out of? It's a super, super interesting question, and it's amazing that there are scientific tools that let us know things about objects that are hundreds or thousands or millions of light years away. That's the topic of one of the first few lectures of the courses. How do we know stuff? Required text, I already said we're using the OpenStax textbook. That's all you need to know. Every once in a while, I may post links to like a news article that I found or some other source of information. But those resources will be available to you as needed. Nothing you need to buy. Course will be asynchronous. My videos are 15 to 30 minutes long. I said all this in the first video. Sometimes I'll post links to other YouTube videos or other stuff that'll all be in those daily pages. And again, I said this in the introductory video, I'll say it again. Treat these lectures like you would sitting in a class. Sit there with a notebook, take notes, don't multitask, really devote all of your attention to the lecture videos. Lab activities, this is a 4-credit science course, which means it satisfies your lab requirement. Obviously, we can't do experiments in astronomy. You don't all have telescopes or radio telescopes or whatever. What can we do in an astronomy class? Well, we can look at data and analyze data that astronomers have taken. We can look at simulations of the sky, simulations of stellar evolution, simulations of the Big Bang, and draw quantitative conclusions from those. So the lab activities will be paper and pencil activities or online simulations, and I try to make them fun. One of the labs is just here's a virtual sandbox that lets you play with pretend lenses and beams of light, and you can make a telescope and understand how telescopes work by making a mock one out of digital lenses inside of a little sandbox. So the labs will be not necessarily every week, but almost every week. Whatever day I assign them, you usually have a week to complete them, and they're not like you might have had science classes where you have to write these long, detailed lab reports with procedure and data and conclusions. It's not like that at all. It's here's an activity, here are some questions, answer the questions, show me the results of your activity. They're pretty straightforward. Drop date is August 22nd. Withdrawal date's October 31st. I think those dates are updated. And the week-by-week schedules in Canvas. As far as your grades, the exams, there'll be a midterm exam, a final exam, and occasional quizzes that count. Well, let's not call them quizzes because quizzes mean something different. Exams that count as exams are worth half your grade. The labs activities are worth 20%. I will drop the lowest 2 lab grades from your average. Weekly homeworks and weekly quizzes are worth 20%. And then just being present in Canvas every couple of weeks, I'll check Canvas just to make sure you logged in that week. And if you didn't, I'll knock your participation grade for that, just to make sure you're keeping up with the course. What else? Grades are usual 90s or A's, 80s or B's, etc. I do usually round exam grades, and I will sometimes round or curve the final grades. Those curves depend on the assignment. I can't tell you what they are beforehand because I don't know what they are until I know what the grades are. The grades kind of determine what the curve are. Late work policy is super important in this class. In order to keep you on track, I'm pretty strict about late work. I will take late work. If it's a day or so late, you'll get 10% off. If it's a week or more late, the highest grade you can get is 70%. And if it's more than 2 weeks late, the highest grade possible is a 50%. Still do it. I mean, 50% is better than a 0, right? But the point of the assignments is to keep you on track with the content. And if you fall 2 weeks behind on the homework, that means you're 2 weeks behind on the content. And that's no good. So get your assignments in on time. If it's a day or 2 late, I might not even notice. It's when it starts to become a week late or 2 weeks late that I really take points off. Online course attendance, like I said, you never want to go more than 3 or 4 days without checking in on the course, or you will fall behind, and you'll fall behind on the assignments. Alexa, stop. Sorry, my Alexa interrupted me. And I will check, like I said, every couple of weeks I'll check Canvas just to make sure you haven't gone more than a week without logging in, so that's important. Academic honesty policy is really tricky nowadays in the days of it used to be just don't copy stuff from Google and paste it into your exam, but now it's we've got to worry about ChatGPT and Claude and Gemini and all these other LLMs. Look, AI is great. I use it all the time. I might use it to create content for this course. But when I give you an assignment and tell you that I expect the answers that you write are your own answers, that's what I expect. And the kinds of questions I ask are usually questions that I can tell the difference between student output and LLM output. So the official policy is with any written work that I tell you should be your own work, AI use is not permitted, and using AI will be considered a violation of academic honesty policy and RBC. Some assignments I will tell you to use AI on, and I will make it very, very clear assignment by assignment which assignments those are. The student support services sections of the syllabi are always the same. All these links are important to know and to have, and they should be in all your syllabi. Yeah, so that's it. As far as the content of the course, what we will be covering in what order, if I click the pages link here and go back to that list of content, we start with a history of astronomy. How did people know stuff about space before telescopes were invented, and what did we know about space before telescopes were invented? How did the questions about our solar system basically lead to the invention of science in the 17th century, what we sometimes call the scientific revolution. We'll move on to talk about the solar system and the planets. We'll spend a couple of videos on each of the planets: Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, and so on. A video about asteroids, a video about comets, all the junk that orbits our sun. Then we'll move out to talk about other stars, other planetary systems, how stars evolve and change over time. And then we'll move further out and talk about distant galaxies and the universe as a whole, including talking about the Big Bang and what we know about the origin of the universe and what we don't know about the origin of the universe, which is a lot. One of the most important and interesting things about a class like this is all of the stuff that we don't know. This is what keeps scientists becoming scientists every year, because there are still questions that need to be answered, and I want to focus on those questions, those unanswered questions, a lot. So that's Canvas. Everything else, the discussions, there's probably nothing even here yet. Yeah, the discussions is not going to be required for you to participate in, but I will occasionally put stuff here, like stuff in the news. Like, you might have heard there's some weird comet from outside of the solar system heading towards our solar system that some crazy scientist from Harvard thinks might be an interstellar spacecraft. Well, that's worth talking about in an astronomy class, right? So I might start a discussion board thing about that. But I'm not going to require you to post here. I'm not going to require you to, I'm not going to monitor the discussions for other people's participation. If you come across a interesting news article, throw in the discussion board, or email it to me and I'll throw in the discussion board. Those are a side channel, though. They're not part of the class. The assignments live here, and these are the only things that you will be graded on. So if you go to questions and quizzes, you should see quiz 0, quiz 1, and the week 1 review are already posted, and you should work on those this first week of class. All right, I'm going to stop talking now, and I'm going to post this up to Canvas, and then you can get started on the real work of the class.